Welcome back to the channel, everybody. This is my second video on PLCs. If you haven't checked out the first one, please go do that now. It talks about some basics of how a PLC works and some concepts that are good to learn about before you actually start programming. I'll try to drop a link to that other video down in the description below. So this video we're going to be doing some simple ladder logic examples and an online PLC simulator. The website's called plcfiddle.com. So if you go to Google and type in PLC Fiddle, it shows up right there at the top. And this is what it looks like when you open it. I'm going to go ahead and clear everything out and we'll start from scratch. Just going to drag everything that it starts with into the trash. Add us a couple of empty rungs so we have some room to work. And then I'm going to delete these variables over here so we can pick up where we left off from the previous video. We'll go ahead and create us some stuff to use. I for input, so this will be a button for us. So we just say button 1. It's a Boolean, so it's a switch. It's either on or it's off in this case. So then we can have I2 for input 2, which would be another button. It'll be Boolean. We can have O for output 1. This can be our LED light. And then in case we want to do some memory, we can do M for memory, M1. We can do internal memory. M1, then we'll go ahead and add a second one. M2, internal memory. Alright, so we added some variables to use. Let's start out with a basic normally open contact, and we can just make it button 1 or input 1. And let's demonstrate. We're going to first talk about these different types of coils that are up here. We're going to start with this one on the left first, and I just call it a regular coil. The way it works, when it receives logic flow, it comes on, and when it loses logic flow, it goes back off. So right now our button 1, you can see that it's off. So if I click this to turn it on, you see how the contacts turn green. That just shows that it's on. So in this case, this terminal on our PLC input card would have power applied to it right now. So the PLC sees that power and says it's on. It's normally open contact, so it turns green, and it'll let the logic flow past it from left to right. And since there's nothing else in the way, this coil can come on. So it's green as well, right? Now if I click our button to turn it back off, you will see that the coil went back off. So that's what I mean. As long as it's receiving power flow, it'll come on. And as soon as the power flow goes away, the coil goes back off. Let's demonstrate the next type of coil. We'll make this one input 2, button 2. When we go back to our coils, this L stands for latch. Since we used our output, let's just do a M1 internal memory. So the way a latch coil works is whenever it receives power flow, it comes on, right? So if I click button 2, if I turn it on, it goes green, the coil comes on, right? That's identical to the way the other one was. But the difference is when I cut the button off, the coil stays on. See right here, it says M1 internal memory is on, and it's green here. So even though button 2 is off, this latch coil stays. That's what they're calling it in this program, is latched. Some manufacturers will call it latch and unlatch, and some might call it a set coil with a reset. So the way this thing works is it will stay on forever until it is unlatched or reset. That's where this U comes in right here. So let's drop us another contact in here. we can make this button 1. Then we can go back and drag the unlatch in here. Alright, and let me clean this up a little bit to eliminate some confusion. Alright, so button 2 caused M1 internal memory coil to latch. It'll stay on forever until this unlatch with the same address receives power flow. So when I cut on input 1, when I cut it on, you see how the internal memory, the M1 went off? So let's do that again. Button 2 cuts it on, right? It's green, it's on. Even if I cut the button off, the coil is considered to be latched and it's still on. You see right here? And it will stay on forever until the unlatch receives logic flow. So when I press button 1, that's going to let the logic flow to this U for unlatch. That unlatches that memory address. So that cuts off that coil. So that's 2 very basic, very commonly used types of coils. I don't have a better name for this one. I just call it a regular coil. This one, you have a latch and an unlatch. Like I say, some brands may call it a set and a reset, but they behave the same. One thing that's important to note is that the thing that connects this latch and unlatch together is this address. Notice they're both using the exact same address of M1. That's what connects them. That's how they know that they latch and unlatch each other. It's because they share that same address. Alright. If you have any questions about that, if I covered that too fast, just drop some comments below and let me know. We're going to move on to a timer. So I'm going to drop a timer down here in our circuit. And we need to create a timer address, a timer variable for it to use. So I'm just going to make one called timer 1, and I'm going to choose the type. This one's not Boolean now because timers count. They're not just on and off. They, accumulating numbers as they time. So it's going to be of type timer. So I'm going to add that. So now we have a timer to work with. So now in this little drop down, I can choose that timer. And we need let's drop a button in there, our input 1, button 1, to cut on this timer. Now one thing you'll know on our variable list that's a little bit different over here, you got this little arrow. When we drop it down, this timer has a couple of things it can do. In this case, and this is going to vary from different manufacturers, but that doesn't matter. The concept's the same in all of them. EN is enable, so this bit should come on whenever the timer's receiving logic flow. TT is very similar. It will be on while the timer is timing. That's timer timing. That's what that stands for. Q will be when the timer gets done. So it is considered to be done when it reaches its preset. So if I set this to be 5, in this case it'll be 5 seconds. Whenever the timer is timed for 5 seconds, this Q bit should come on. ACC is the accumulator, so we should be able to watch this number increment as it is timing. So right now it's holding at 0 because it's not receiving any program logic flow. Our button is off. When I cut the button on, you can see the enabled and timer timing bits are on. You can see the accumulator was counting until it reached 5, and then our Q bit came on. So let's do that again. Let me make it a little bit longer so we can watch it better. Let's make it 10 seconds. Alright, so I'm going to cut the button back on again. You can see the accumulator value is incrementing as time goes by. It's timing right now. We've got these 3 different bits that we can use to manipulate things. So if we wanted some type of delay, Let me cut it back off. When this timer loses logic flow, power flow, it's going to reset itself. So our accumulator's sitting on 10 something right now. When I cut it off, it's going to go back to 0. Let's do something. Let's make our light come on after 10 seconds. So I'm going to put our output's going to be our output 1 LED light. Our variable 1 was going to be timer1.q. So when I press the button, the LED light is going to stay off until the timer reaches its preset value of 10 seconds. And then this Q bit is going to come on and turn our light on. So let's demonstrate that. There we go. So our timer is now incrementing. The Q bit is off, but once it reaches our preset of 10, it's going to cut our light on. And then when the timer loses the logic flow, when I cut the button off, you know, our accumulator is going back to 0, so our light's going to turn back off. Oh, I double clicked it, I cut it right back on. So we'll watch it again. So it's back counting again. When it hits 10, boom, light's back on. So we'll cut it off. This time we're going to pick the TT bit, the timer timing. This is going to completely change the way the light behaves. Instead of waiting 10 seconds and then cutting the light on, this is going to make the light come on immediately when the button's pressed, and it's only going to be on for 10 seconds, and then the light's going to go back off. So I'm going to press the button. See, light's on right now. While the timer's timing until it gets to 10 seconds, then the light's going to cut off. Right there. So the main thing is to be aware that in some programs, timers have different individual bits or different properties, however you want to look at it, that you can use and monitor to make different outcomes. So with the same timer, you know, in this case timer 1 address, with the same timer we can make something last for 10 seconds, or we can make something wait 10 seconds before it happens. So a lot of different uses. Really that's all set. No ACC is the value that is you can see while it's accumulating. PRE is preset. That's your threshold. And once it's reached, timer's going off, the Q bit's coming on. So again, if I didn't do a good job of explaining that, you want more information on timers, drop a comment below and I'll make it happen. We're going to move on to a counter to demonstrate that. It's going to be very similar to what we just did. So let's pick button 1. We need to make a variable. We just call it counter 1. We're going to add that. Notice it's got the little drop down arrow too. So like I was saying, almost the same as the timer, very similar. Let's make our preset 5. The accumulator is the current value of the counter, which is 0. Oh yeah, we need to set our counter to our variable. And then we've got an enable bit and a Q bit. So let's watch what happens. When we got input 1 connected to the counter. So when I cut the button on, the enable bit comes on because it's receiving logic flow or power flow right now. The accumulator counted to 1 because I pressed the button 1 time. When I cut it back off, the enable bit went off because it's no longer receiving power flow. So every time I cut this button on, it's going to increment that counter by 1. So we got 3, we got 4. Now when I hit it one more time, the accumulator is going to be 5, and that's going to match our preset threshold value of 5, which should make our Q bit come on. So here we go. Boop. So we hit it 5 times. Our Q bit has come on because the accumulator met the preset threshold. One difference between the timer and the counter is the resetting back to 0. How do you reset this counter back to 0? You know, we've done something 5 times and we made something happen. How do we get it back to 0? And this simulator here, we have a reset instruction. Different manufacturers are going to have different ways of resetting the counters. Sometimes it may be a separate instruction like this. Sometimes the counter may have it built into that instruction and it just needs another branch or another rung connected to that same instruction to reset it. It doesn't matter. The concept is the same. On a counter, you need some way of resetting it. So in this case, we'll make button 2 reset it. So it's back to 0. So let's click button 1 5 times, make it reach the threshold right there. So our Q bit's on. To reset the counter back to 0, I'm going to press button 2. There we go, reset back to 0. The way that can work is they're sharing these 2 separate instructions, a counter instruction and a reset instruction, are sharing the same address. That counter _1 address in both of them connects each other. Alright, so let's do something with the counter address like we did a while ago. We'll make our counter 1 Q bit. We'll make that turn on our light. Alright, so the way this is going to work, because I picked the Q bit, after we've pressed button 1 5 times, our light's going to come on. So 1, 2, 3, 4. Notice the light's still off, but once I hit it one more time, 5, this Q bit's going to come on because our timer has reached this preset threshold that I set of 5. So right there, even when I let off the button, this Q bit's going to stay on forever until it gets reset. So even if I make this counter keep counting, it doesn't matter. Right now it's on 8. It's above 5. It's 5 or greater, so that light's staying on until I reset the counter back to 0, which button 2 will do. So when I press button 2, counter's going to 0, light's going off. Right there. So that is counters, timers, a regular coil, and a latch and unlatched coil. That's very common instructions that you'll see in any brand PLC. It's just a quick demonstration. Let's follow that up now with a demonstration of a circuit. Something a little, just slightly bit more to it. So let me erase all this stuff and then we'll move on to that demonstration. Alright, clean slate. So here we go. Alright, in our demonstration, we have got a grinder that's going to grind some material. The shavings are going to fall into the hopper. Once it does that 5 times, the grinder motor comes on and off 5 times, our hopper will be full. We will open a valve on the bottom of the hopper for 5 seconds to let all those shavings empty out of the hopper, and then it'll be empty and we'll be ready to start again. So we're going to try to program that now. So the key points are start and stop the grinder motor 5 times. After that happens, the valve's going to open the bottom of the hopper for 5 seconds. So we need a start button, stop button, a counter to count the 5 times, and a timer to do the 5 seconds. Hold that valve for that bottom of that hopper open for 5 seconds. Then we can reset everything and be ready to go again. Alright, so let's recreate our variables. I1, we'll call this start. Push button. Make it Boolean. Have I2. Stop. Push button. Let's do M1. M1. Internal memory. We're going to call this one motor running. Boolean. Alright, so we got our motor 1 running. Let's do our output 1. We're going to call it run grinder. Boolean. Let's do our output 2. Open valve. This is for the bottom of the hopper. Again, that's Boolean. It's just, solenoid valve. Open it or close it. Let's make our timer. Let's make our counter. Alright. We know we wanted our timer to be a 5-second timer, so let's go ahead and get that set up. We wanted our counter to be 5 times. We're going to say our hopper's full of shavings after that motor's ran 5 times. Let's start programming it. So, start button. And I said this in the last video, but there's more than one way to program something and get the same result. So if you're questioning why I'm programming it like this, you think you have a different way, that's perfectly fine. There's plenty of ways to program this and get it all to work the same way. You'll get the same outcome. Alright, so this one, start button, I make the motor, and this is just the M1, that's just the internal memory. We need to use that to actually cut our grinder motor on. So M1 is going to cut on our actual physical O1 output. This would be connected to, a relay, some type of motor starter to make our grinder motor run. And then we're going to say, let's do our counter. And I'm going to make this a normally closed contact, and you'll see why I'm doing this later. I'll explain this in a minute. I'll make this counter 1. See if it counts. I'm going to make our counter start out with 0. We'll talk about this in a minute. So that's going to make our motor, grinder motor start and stop. That's going to make it count. Then we said after it does it 5 times, so we want our counter.q. After it does it 5 times, then we want to start a timer, and we want that timer to hold our valve for that hopper bottom open, which would be output 2. So we want that to happen for 5 seconds. So we're going to do our timer timing bit. So press the start button, the motor memory latches, which in turn, same address right here on this normally open contact, that's going to turn on our actual grinder motor. Once we stop the button, it becomes unlatched. That's going to make our counter count up 1 time. So I wanted to make the counter increment, after we've ran the motor. So it runs, grinds some shavings into the hopper, and when we stop it, then we count. Alright, that is 1 run. Alright, so once the counter reaches 5, then our timer 1 is going to start timing. It's configured to be a 5-second timer right here. I've got the preset threshold set for 5, which this is a 1-second timer, so 5 is 5 seconds. This TT bit is the timer timing, so as the timer is incrementing to 5, it's going to be on, and that's going to open up our output. This is a real physical output, something you can touch. It's going to have wires connected to a solenoid valve. Open the bottom of the hopper, and then once the 5 seconds have been reached, we need our timer1.q bit. We're going to use that to reset our counter 1 back to 0, and that's going to reset everything for us. So let's step through this. Start with the counters on 0, so I press our start button. Notice the latch bit came on. It stays latched. It keeps our grinder running until I press stop. Once I press stop, this normally closed contact right here, it's going to go green. It's going to let the logic flow to our counter. So I press stop. See how it's normally closed and it's green? It's the same address as it's normally open, but normally open and normally closed, you know, are opposite of each other. So even though they share the same address, these are going to always be opposite. So when I stopped the motor, it made this counter receive program flow, which made it increment to 1. So let's do it again. Motor's running. If I stop it, we're going to increment to 2. Grinder's running again. See right there, it's green. Over here it says on. I stop it. That's 3 times. It's running for the 4th time. When I stop it, it increments 4. Alright, this is the 5th time it's running right here. So when I stop it, it's going to make our counter reach the preset threshold of 5, which means this .Q bit is going to come on right here. The counter 1.Q is going to come on. It's going to make our timer start timing. We're going to see it right here. So, alright, timer's going. See, our valve is open right now for 5 seconds. Once the timer reached its threshold, it cut this reset bit on, which took our counter back to 0. If we go look at our counter now, it's back on 0, which means everything is ready to start again, repeat the cycle again. So let's walk through that one more time. Start the motor. Counter's on 0. There's 1 time, 2 times, 3 times, 4. Alright, the motor's running right now for the 5th time. The way I have it programmed with this normally closed contact, it's not going to count till I stop the motor. But once I stop it, our timer's going to start incrementing, which is going to, the TT bit, I'm using the TT bit right here, it's going to come on immediately, and it's going to last for 5 seconds because it's the 5-second timer. That's going to open our valve for 5 seconds. Once it reaches 5 seconds, this Q bit, which is a different bit of that same timer, but you know, TT, like we saw earlier, TT and the Q behave differently. So once the 5 seconds are up, this Q is going to cut on and reset this counter. So here we go. I'm going to stop the motor. Alright, so we're counting. Our valve is open. Once it reaches 5, it reset our counter for us. It happened really fast. It's kind of hard to see, but that's what happened. This came on for a split second, reset the counter, and then when it resets the counter, this Q bit up here goes off, so that resets our timer for us as well. So everything is reset. See, the counter's on 0, timer's on 0, everything's reset, ready to go. We'll do it one more time right quick. So 1 motor, or 1 time, 2 times, 3 times, 4 times. I tell you what, I'm gonna make the timer a 10-second this time, just so we can look at it a little bit longer. So now we got a 10-second timer. When I stop it, see, our counter's on 4, so when I stop at this 5th time, so I gotta start it first. Now it's running the 5th time. When I stop at the 5th time now, see, timer's incrementing. Timer timing bit's on. It's got our valve open. If you watch this close, you go 8, 9, 10. You saw the Q bit go green for just a second. And that reset the counter. That reset the counter, which in turn reset or turned the power off to our timer, and everything's back to 0, ready to go again. So, kind of quick run through of everything, but some good basic concepts of those handful of instructions for you to use. I like this little online simulator. It's nice and easy. It's got some basic stuff on here for you to play around with. I highly recommend using it. It's free, doesn't require any downloading of anything. I did have a problem. I think it wouldn't work with Internet Explorer, but I'm on Firefox right here and it's working great on Firefox. So that's all for this video. If I can get some interest, if people like it, drop me some comments or subscribe. Let me know if you like it, and I can keep doing more and more of these videos. So that's all for today. Thank you, and bye.